Hello, everyone. Welcome back to the course of Microcontroller Unit, MCU, Application Technology. In various events or performances, we often see a wide array of stage setups and stage lighting. Many stage lights are constantly changing, creating stunning effects that captivate the audience. In this lesson, we will learn about the design of stage lighting control. The task of this project is to simulate and design a dynamic control program of stage lighting. The primary objective is to further study the analysis of multilevel nested if statements. Next, we will cover the following three main topics. First, understanding and connecting peripheral circuits. As shown in the diagram, apart from the minimum system working circuit of the microcontroller, the required peripheral circuits include: for individual push-button switches connected to the microcontroller's P1.0, P1.1, P1.2, and P1.3 pins. 5 independent LEDs connected to the microcontroller's P0.0, P0.1, P0.2, P0.3, and P0.4 pins. Additionally, when the P0 port is used as an input, an external pull-up resistor, typically a 10 kΩ network resistor, must be connected. The circuit shown in the diagram includes a 10 kΩ network resistor. Tip: the P0 port differs from the P1, P2, and P3 ports in that it lacks internal pull-up resistors, making it unable to output proper high or low levels. Therefore, when using this set of I/O ports, an external pull-up resistor is essential. Second, circuit simulation. Launch the Proteus simulation software, draw the schematic diagram of the simulation circuit, and run the simulation. Step 1. Open the simulation diagram of microcontroller minimum system circuit. Step 2. Add and place the pull-up resistor. In component mode, click the Component Selection button, P, to open the Component Selection dialog box. Enter RESPAC in the keyword field, locate RESPAC 8, double-click it to add it to the component list, and then place it in the schematic editor as shown in the diagram. Step 3. Place resistors and modify parameters. In the component list, click on RES to select the resistor component. Place 5 resistors in the appropriate positions, and double-click each to open the component edit dialog box. In the resistance field, change the value to 510 ohms. Click the OK button to complete the parameter modifications. Step 4. Place LEDs. In the component list, click LED red, select the LED, and click the clockwise rotation button to rotate it 90 degrees, with the negative terminal to the right and the positive terminal to the left. Place 5 LEDs in the appropriate positions in the circuit. Step 5. Place buttons. In the component list, click Button, select the push button component, and place 4 buttons in the appropriate positions in the circuit. Step 6. Place the power source and make connections. Select terminal mode, click Power, place the power source in the circuit, and connect the circuit as required. The completed stage lighting control circuit is shown in the diagram. Step 7. Add the stage lighting control.hex file. Double-click the microcontroller component to open the component edit dialog. In the Program File option, click the folder icon on the right, locate the compiled stage lighting control.hex file, and click OK. Step 8. Run the simulation. Click the Simulation Run button in the lower left corner to observe the simulation results. Next, compilation and download of program. 1. Writing of program. Step 1. Create a folder named Project 8_1 under D disk, microcontroller study plus name. Step 2. In the Project 8_1 folder, create a new project named Project 8_1. Step 3. In the Project 8_1 project, create a new file named Project 8_1.c. Note: refer to the previous course content for detailed steps 1 to 3. Step 4. Return to the editing interface of the newly created project and input the following C language source code into project8_1.c. Step 5. Save the program after inputting it. Tip: the symbol tilde denotes negation. The statements bit power and power equals 0 can be combined into bit power equals 0 in a single statement. 2. Compilation and download of program. Refer to the relevant content in the previous course for detailed steps on program compilation and download. Power on the microcontroller. Pressing the Power button will allow you to control the on and off state of the LED 0 lamp with the independent push button switch KBY1. Pressing the independent push button switch key 2 will cause the LEDs LED 1, LED 2, and LED 3 to flash in sequence. Pressing the independent push button switch key 3 will turn on LED 4, releasing the button will turn it off. The actual effect is shown in the video. In this lesson, we simulated the design of a control program of stage lighting, delving into the multilevel nested application of if statements and mastering the setup of peripheral circuits and the use of Proteus simulation software. We achieved control over multiple LED lights on and off and flashing effects through button presses, reinforcing our knowledge of microcontroller programming and hardware interfaces. Finally, I will assign a few exercises to reinforce today's topics and deepen your understanding. Please complete them diligently. That concludes this lesson. See you next time.